Hey guys, today we are going to find equations of parallel and perpendicular lines, and in doing so we're also going to work with standard form of an equation, which is one that we may use a little bit less often. When lines are parallel, when the equations are of parallel lines, the slopes are going to be the same. If lines are perpendicular, then in their equations you'll find that the slopes are opposite, meaning that the sign is opposite, and reciprocals, which means the fraction will be flipped. And standard form of a line is ax plus by equals c, or ax plus by plus c equals 0. But we should note that the c's in these two different cases are going to be different signs, because you've got one on one side or one on the other. If you switch sides, the signs are going to be different. So first we are going to determine whether these two lines are parallel, perpendicular, coinciding, which actually means exactly the same line. So one line on top of the other, which makes the same line, or none of these. So we need to find the slope. So for this first equation, if I move the x to the other side, I get 4y equals negative x plus 16. And divide everything by 4, I get y equals negative 1/4 x plus 4. So my slope is negative 1/4. For this second line, if I move that 3x to the other side, I get 12y equals negative 3x plus 24. So if I divide everything by 3, I get y equals negative, and then 3 over 12 is 1/4. And then 24 divided by 12 is 2. So I have the same slope. I'm going to make a note. Same slope, and m is for slope. When I have the same slope, my lines could be parallel or they could be coinciding. So I look at the y-intercept. I have a different y-intercept. Okay, 2 and 4. Same slope but different y-intercept means they are parallel lines. If they were the same slope and the same y-intercept, they would be the same line, so they would be coinciding. All right, now, this line, we've only got one, and it's really just standard form, just the original standard form. It's not really any particular line, but we're going to get something out of this. If we put it into slope-intercept form, we get by equals negative ax plus c. And if we divide every term by b, we get y equals negative a over b plus, or x, plus c over b. Okay, so from this we can get that the slope from standard form, the slope will always be the opposite of a over b. And the y-intercept will always be c over b. And we can use that on example 3. In the first line, a is 1 and b is 1. The slope is the opposite of 1 over 1. Opposite of a over b. So the slope is negative 1 for the first line. For the second line, the slope we have an a of 1. Opposite of a is negative 1, and b is negative 2, so the slope is positive 1 over 2. Those slopes are not the same, so the lines are not parallel. Those slopes are not opposite reciprocals. They are opposite signs, but they are not reciprocals of each other. So they are not perpendicular either. So these are just two lines that intersect somewhere. They don't happen to form a right angle. Example 4, the opposite of A is negative 3, and B is 9. Negative 3/9 is negative 1/3. Here, in the second line, opposite of A is negative 1. So the opposite of A is negative 1, and B is 3, so I get negative 1/3. Same slope, which tells me these lines are either parallel or coinciding, so I better check the y-intercept. So back to this first line, the y-intercept is C over B, so that's 18 over 9, which is 2. And for this second line, the y-intercept, C over B is 6 over 3, which is 2. Same slope, same y-intercept. And that means they are exactly the same line, so these are coinciding. So our next set of lines, the first slope, opposite of A is 2, B is 5, so the slope is 2/5. The second line, the opposite of A is negative 5, B is 2. These are not the same slope, so they're not parallel or coinciding. They are opposite signs, and they are flipped versions of each other. So they are opposite and reciprocals, which means these lines are perpendicular. Perpendicular, by the way, we can abbreviate with that perpendicular sign. So next we've got a slope with the opposite of A being negative 2. B is negative 3. So 2/3. And the second line, opposite of A is negative 6. B is negative 9. Negative over negative is positive. 6/9 is 2/3. So we've got the same slope. So we check the y-intercept. Sorry, I keep pausing this. I'm just trying not to cough. But when it comes, it comes. So the y-intercept is C over B, 7 over negative 3. And the second y-intercept, negative 11 over negative 9, which is 11/9. Same slope, but different y-intercept means these lines are parallel. There is a parallel symbol as well. We could just put those 2 slashes. That means lines are parallel. So here the first line, opposite of A over B. And the second line, opposite of A over B. It looks like our slopes are opposite signs and reciprocal, so these lines are perpendicular. Opposite of A over B is 3/2. Opposite of A over B, negative over negative is positive. 4 goes in 3 times and 2. We've got the same slope, so we need to check the y-intercept. C over B is negative 6. And then (48) over -8 is also -6. Same slope, same y-intercept. These lines are coinciding. Standard form of a line, ax plus by equals c. We're going to write ours in this order. Sometimes people keep the c on the left side. We're going to keep the c on the right. A, b, and c must be written as integers. So there's no fractions or decimals. And a, the lead coefficient, must be positive. So we are going to write a line in standard form, the line being parallel to this given line, and it's going to pass through this given point. So for this line, opposite of A over B is -5/3. So the slope of a parallel line is also -5/3. So the slope that I'm going to use is -5/3, and it has to pass through 610, so that's an x1 and y1, and we're going to use point slope form. Y minus y1 equals m times x minus x1. We're going to start there and end here in standard form. So we've got y minus 10 equals -5/3 times x minus 6. So y minus 10 equals -5/3 x plus, and then 5 times 6 is 30, divided by 3 is 10. So to get into standard form, I need this x term over to the left side, and I need this constant term over to the right side. So I get 5/3 x plus y equals 20. So there's one problem that we still have to fix, and that is that we don't have all integers. So to fix that, I could multiply all terms by this denominator, 3. 3 times 5/3 is 5, times y times 20. Okay, so here's another one with the same set of directions. So first, the slope, opposite of A over B is 2/5. And there is my x1 by y1. The slope of a parallel line is also 2/5. So y minus 1 equals 2/5 times x minus 5. So when I distribute, I get 2/5 x minus, and then 2 times 5 is 10, divided by 5 is 2. So I need to get my x term to the left, my constant to the right. So I have -2/5 x plus y equals -1. So now I have two problems. One is that I don't have all integers, and two is that my lead coefficient is not positive. So I can take care of the fraction by multiplying by the denominator, and I can make my lead coefficient positive by multiplying by a negative. So I need to distribute a -5. So I get +2x negative 5y, and positive 5. Nearly the same instructions here, except this time we're doing a perpendicular line. So I still start with the slope, opposite of a over b, which is negative 7, so I get 3/7. But now I want the slope of a perpendicular line, which is the opposite reciprocal, which is negative 7/3. And there's my x1, y1. Y minus y1 equals m times x minus x1. So I get negative 7/3 x and positive 7 times 12 divided by 3. I could do the 12 divided by 3 now, which is 4, times 7 is 28. Move that 7 over, move the negative 7/3 x over. And then 28 plus 7 is 35. And we have to multiply by that denominator. So I get 7x plus 3y equals 105. And last, the slope of this line opposite of a over b is negative 3 over negative 6, which is 1/2. So the slope of a perpendicular line is the opposite reciprocal, which is negative 2. And there's my x1, y1. So y minus y1 equals m times x minus x1. So y minus 7 equals negative 2x plus 10. I'm going to move the constant in that variable. 2x plus y equals 17. I have all integers. My lead coefficient is positive, so I can leave that just as it is.
Let's end this lesson with a little algebra review. So these are some skills that will be really useful as we go forward in this class, and there are also some skills that we struggled with a little bit on our recent quiz. So first, by order of operations, I need to take care of parentheses, but there's nothing I can actually do inside these parentheses, so I go to this exponent. Okay, so 3x plus 7 squared. Anytime we have a binomial squared, I want to remind you that it comes out in the form, so we'll say a plus b squared comes out in the form of a squared plus 2 times a times b plus b squared. Okay, so using this form as a shortcut is a nice, effective, and efficient way of squaring this. So I've got 5 minus, and then a squared would be 9x squared, 2ab, so I multiply these and get 21x, and then I double that and get 42x, so plus 42x. And then plus b squared is plus 49. So that's effective and efficient. Also effective, maybe not as efficient, would be to take this binomial and multiply it by itself. So I distribute the 3x and then I distribute the 7. Okay, still effective, not quite as efficient, but it gets the job done. Next, I multiply or divide, and I have a negative to multiply, so I distribute that. So 5 minus 9x squared minus 42x minus 49. And then I can combine a couple of like terms. So I've got negative 9x squared minus 42x, and then 5 minus 49 is negative 44. Then I want to subtract these two expressions. So in order to do that, I need a common denominator, which is going to be x minus 4. So I have to multiply top and bottom by x minus 4. Okay, so I've got 8 over x minus 4 minus, and then I distribute 2x times x is 2x squared. 2x times negative 4 is negative 8x. 5 times x is 5x. 5 times negative 4 is negative 20. Okay, so now I can combine some like terms here. I'm going to put this into one fraction, 8 minus 2x squared minus 3x minus 20 all over x minus 4. Okay, and then I need to distribute this negative. So I've got 8 minus 2x squared plus 3x plus 20 over x minus 4. And then combine my like terms. So I have negative 2x squared plus 3x plus 28 all over x minus 4.